Good afternoon, everyone, and welcome to Layer by Layer, the show about 3D printing and our place inside the industry. Today, we're going to talk about a number of metal 3D printing startups that have raised over $16 million this past week, some updates at Xometry, and then what Context has found out about consumer 3D printer sales, as well as finishing up with what is needed for the industry as a whole to just grow more. But before we do that, let's go ahead and pay the bills. This episode is brought to you by the Slant 3D, Etsy, and Shopify plugins. If you want access to hundreds of 3D printers to support your e-commerce store throughout the holiday season so that you don't have to worry about keeping your machines operational as well as packing and shipping all the orders coming in, check out the Slant 3D plugins. Working with both Etsy and Shopify, these plugins allow you to focus on your customers and making better products rather than having to worry about printing parts, maintaining machines, and packing up boxes. They are free to sign up for, and you can play around with them anytime. Go ahead and check out the Slant 3D print-on-demand plugins at either Shopify or Etsy. Yeah, both of them are running, both of them are doing well, but not the topic of conversation right now. So we're going to go ahead and dive right into the news, starting with Bambu Lab releases AI Printmon Maker. So, I'll read the blurb. The new artificial intelligence offering has been in beta since August and seeks to encourage creativity and lower the barrier to entry for 3D modeling. Notably, the generative AI platform produces models optimized for multicolor 3D printing. Printmon Maker is integrated into blah, 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 blah. It works with Bambu Studio. So, what they have done is they have made what is effectively a little bobblehead maker for Printmons. They're Pokemon creatures that you can modify yourself. And basically you type in a description of your creature saying, I want eyes and ears and so on and so forth in this color. And it will generate a model for you, which is pretty darn nifty and is being worked on by a number of different folks. But Bambu Lab has it released, and they've released it on MakerWorld. Comment on Bambu Lab in this context. They have executed beautifully in making sure that the barriers to entry to 3D printing are lowered. So, printers are tough to work with, so they made a printer that was more reliable. Printers are too slow, made a printer that was faster. Printers are too expensive, made a printer that was cheaper. Filament is tough to get a hold of and tough to tune in. Well, make filament that automatically works with the printer and still make it affordable. And then, I don't know how to do CAD. Here are a bunch of CAD generation tools on MakerWorld. Like, you have to appreciate the quality of the execution of that organization. And I so do. As to this particular executional action, I don't think this matters. I think this is a gimmicky, but it's also really good as like a practice run. It's a baseline where Bambu can experiment to see how people respond with it, how people engage with it, and it's a way to wrangle AI. This is the toughest part. Like the 3D model generation right now is actually pretty darn good. The challenge with it is how do you keep it under control so that it doesn't just go off the rails. With text-based bots, this was hallucination. With AI-generated bots, it's understanding reality in a consistent format. Center doesn't always mean the center. Like if I say put a hole in the center of this part, most of us would interpret that as like a hole going through the entire part, but they might just put like a little cylinder Boolean removal in the center of the part. That's what the AI could do. So wrangling these things is a little bit difficult. But good on Bambu Lab for doing this, and yes, working to reduce the barrier to entry there. That is fantastic. Okay, now Xometry. Xometry appoints former Raytheon Technologies executive Roy Azevedo to board. Azevedo? I apologize. According to Xometry, Azevedo, the former president of two of Raytheon Technologies' business unit, brings significant expertise in engineering, global manufacturing, and supply chain and management to the company. He is joining the board. In his more than 3 decades with the aerospace and defense, he has prominent leadership, blah, 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 blah. He is an engineer by trade. Roy is a highly regarded executive whose background in engineering and deep expertise in global manufacturing and supply. Okay, Xometry is bringing on a guy who knows supply chain and advanced manufacturing in high-tech areas because Xometry is that's where they make their money. On aerospace firms and other high-margin industries that can afford to have quickly machined parts. Xometry is a fast-growing company with compelling business proposition and a significant runway of growth ahead of it, Azevedo said. Added, I understand deeply the importance of digitizing the entire product lifestyle from engineering and design to production and delivery. Xometry's growing portfolio of AI and machine... AI buzzword statement in the statement. They brought on another guy from Raytheon who's joining the board. That's great. Xometry... This is 3D printing news, but this is 3D printing tangential news. Xometry is a machining resource. Maybe we got a molding, that kind of stuff. But to say, would we say 3D printing? I don't know if we'd say 3D printing. That's a stretch. But anyhow, okay. Ex-SpaceX engineers land $14 million to scale new method of metal 3D printing. Fascinating that this came up after last week, where we discussed metal 3D printing in a reasonable amount of depth, both in the podcast and in the comments. But moving on. So they've landed $14 million. What are they building? Armed with $14 million from NVIDIA and Boeing, Freeform aims to change the way building a new metal additive manufacturer that it says changes the game. And yes, there's an AI angle to it too. Blah, blah, blah. This is TechCrunch. Yes, AI inside of it, whatever it was. They have to have AI, otherwise they don't get the SEO. Okay, we saw the potential of metal 3D printing. It has the potential to transform basically any industry that makes metal things, but adoption has been slow and success has been marginal at best, said Paltish. Why is it not practical to use at scale? Fundamentally, because of three things: crappy and inconsistent quality, speed, commercial printers are very slow, and cost. The price of these printers is astronomical. Sounds like we've discussed this before. Anyhow, they concluded that they could operationalize the process to provide a printing service rather than sell a printer. They could crack the whole thing wide open. So they joined up with Tasso Lapas, a former CTO at Velo3D, to start Freeform. The primary mistake most companies were making was using the likes of CNC machines, which are commonly used as a model for the metal printing business. In that case, you sell the machine and its software, make it work for whatever shapes and processes you can use. But metal additive is different. The way these things work today is they're open loop. They're basically playing back a file, he explained. They need to be smarter than that. Yeah, selling people a machine and saying become an expert to make it work, good luck, isn't a recipe for success. Yes, they're aware of all the problems. Cost and complexity of the operation and the fact people don't know how to use 3D printing. Quite frankly, this conversation is like the pitch deck of Slant 3D when we got started. Slow, crappy, and expensive, and nobody knows what to do with it. We solved the nobody knows what to do with it kind of with this YouTube channel. That was the intention of this stuff. Package a printer into a box, blah, 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 blah. They're creating a 3D printer service for metal 3D printing, and they're using closed-loop AI control of the machine in order to improve the print quality. That is what they're doing. The closed-loop system with real-time monitoring mitigates the quality issues while still allowing speedy printing of complex geometries. And by operating as a 3D printing service, they keep the business model simple. But making that part of the system require the second technology to actually perform that monitoring, blah, blah, blah. Yes, they're a metal 3D printing service, and they have found the tech by which they can monitor build quality. This is something Relativity has fought with and developed. This is something 3DO has worked on. 3DO, I don't know how much feedback they have in their actual print, but they took on the model of let's do a service and we'll build a proprietary machine in the background so that we can create a better service. Their approach has taken time to grow from theory to reality, but they're methodical. They have customers in the autospace, automotive, industrial, and energy sectors. The whole nine. They declined to put any on the record, but did mention they're making everything from rocket engine components to exhaust parts for Formula One cars. They plan to use the money to scale up, build up their next generation of much faster printers, and hire up to about 55 people total over the next year. It was a Chilos. I will look back at it with 6 people. We built from scratch the fastest laser melting platform on the planet and the hardware and software for it. We did think people said, yeah, blah, blah. Startup stuff. Sorry. We did things we couldn't say and nobody else did. Every startup has done that. We have done things here nobody else has ever done before. That is definitionally what a startup is. If you are doing things everybody else did, you don't have a company. So it's kind of, I hate when people use that phraseology, which makes me a terrible salesman because my golly, here at Slant 3D, we're doing things nobody else is doing, but it's so trite. Okay. But they are using a laser metal printing system, and they have feedback on it to make sure that they're actually doing good quality prints. I wish them the best. Metal printing is hard, it's rough, it's brutal, and in this particular area, it is competitive. And they have the problem of both generating the hardware and acting as a service. And they're going to find out the dirty little secret with services. The dirty little secret with services is that they did not solve the problem of people do not know how to use the stuff. Garbage in, garbage out. This is the gigantic challenge of services. When you have a service, what do you offer to the customers and how do you corral them? If you offer a lot of customer support, then you get bled to death because you need high-level quality engineering customer support, basically designing the part for the client, but you're not a design firm. You're a 3D printing service. Or you have an automated system that just automatically does it fine, and that never occurs because people feed in something that doesn't work in the system. Literally right now, I hate to keep on bringing this back to us, but like in our API, we have people who will like submit parts, and they will have a part that is down against the bed and a part that is 1/4 millimeter up from the bed. And that's the part. It's going to fail in print. So we have to manually fix it or communicate with the customer or send them garbage so they learn. We try not to do that. Generally, if we see failed parts, we will readjust them and we will send the failed part and the good print along with it so the person learns. And quite frankly, that is more efficient and effective than sending an email. We just write print not on bed, modify file on the damaged print and throw it in the box. That's the operational way we train people to use the systems well so that they can be successful with them. But you can't get in an email chain where it's like, send me photos, there was a problem with your part, I don't understand, this, that, and the other thing. Here's the part. That's how we deal with it. But all of that is to say that running a print service is really hard. And when you're doing engineering level stuff, it is very, very hard. Great margins inside of it. And the tech that they have will be valuable, but it is brutal as a service. Everybody sells machinery because there's so much R&D in the front that machinery is the fastest way to recoup that investment cost. Service does not. Okay. And by the way, for everybody out there who's seeing these investment numbers and discussing them, $14 million. For the investor, for that to be statistically significant to the investor, they need to have at least a 5 to 10x return on that. If they do it through an equity sale where the company increases in value 10x, fine, then they sell it off to the next guy, but that's tulip bulb trading. Generally, if it was a traditional sort of business, then that company needs to throw off $140 million of profit over the course of 10 to 20 years to make this a usable business. Now, over 20 years, that's not unreasonable. Most companies, successful companies that get up to some level of even lame duckness, throw off enough profit for about $1 million per year. So over 20 years, that investor would recoup their investment. That is not taking into account inflation and losses and blah, 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 all the things. But that's the expectation. When you take this money, you are taking the responsibility of attempting to give back 5 to 10x of what they gave you. Okay. Other metal 3D printing news. Fortius Metals raises $2 million to boost metal 3D printing in aerospace and defense. Competitor, maybe, I don't know, maybe. Fortius Metals, a Colorado-based startup specializing in metal 3D printing, has raised an additional $2 million in seed funding, bringing its total to the round to $5 million. The new investment includes strategic parts. Yeah, a bunch of people invested. Major organizations, they work with organizations like the Navy, the Air Force, NASA, by offering robotic welding process expertise and proprietary predictive toolpaths. The company enables precise fabrication of complex designs that were previously impractical due to material limitations. That is eerily similar to what Freeform just did. These guys create a reliable printable system or model, and the other guys are building a system that can create reliable printable parts. So they're all working at the same chestnut here. The organization plans to launch additional wire alloys with advanced properties in 2025. Signals a strategic. Fortius Metals is pushing the boundaries of wire-based additive manufacturing. Yes. Fortius Metals makes welding-based 3D printing filament, basically, and the systems and methodologies by which to print with it. Okay. Yeah, good for them. This is a much safer investment because the materials will definitely be necessary. Which machines use that material might be a little bit more ambiguous and higher risk, but higher risk, higher reward. Best of luck to Fortius and the Freeform teams. By the way, again, I had mentioned this at the beginning of the conversation. We talked about metal last week in the video and in the comments, and these two metal 3D printing stories were not planned or intended for this week, but here they are. Okay, next piece of news. The context report. I am excited about this. We have a lot of stuff to cover, and the context report is a lot. Context reports explosive growth in entry-level 3D printing shipments, decline in industrial printer revenues, a concern. This is per TCT. Q2 sales of entry-level 3D printing systems continued their explosive growth, and industrial printers revenues raise concern. Entry-level shipments for Q2 2024 saw a 65% growth against Q2 2023, up 65% from last year. Dems is 2015 numbers. That's better than 2015 numbers. That is fantastic. There was a 17% decline in industrial printer revenues. So the 17% decline is likely attributable to the general economic climate and debt and corporate spending, blah, 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 all those things. The 65% growth in Q2 is holy, it's Bambu. Let's face it, it's Bambu. And what they did, they made printers usable by a wider swath of people. So there is this whole enlarged pie that they sell into because they're the only ones who offer that solution. No one else was ready. And they're taking some pie from other printers too, but if you can't keep your own customers, is what it is. The 7% growth in 3D printer revenues overall is mainly driven by shipments of entry-level 3D printers, with revenue in this category up 58%, higher than Q2 2023. Revenues in all segments declined compared to the previous year, with the sharpest drop in the professional segment. Entry-level printers accounted for 48% of global system revenues during the quarter, surpassing industrial systems to become the top grossing price class. This is new. Entry-level printers, meaning printers less than $2,500, garnered the majority of revenues for the first time in 3D printer history. Now, I don't like the analogy of the PC to the mainframe, but in this case, it applies. This is the swarm of general consumers using these. Now, I have been very vocal repeatedly about the fact that I do not believe in 3D printers inside the home. I do not think that that is where it ultimately ends up and where the ultimate majority of market ends up. Because these printers are still bandsaws. Even Bambu Lab, it's a really nice bandsaw. It can be in every shop. It will not be in every kitchen. Just is. Now, I think 3D printers have the potential to be a little bit larger than like bandsaws as a market as a whole, because they have a larger breadth and more capability than a bandsaw does. But right now, the 3D printing market is $5 or $10 billion, and I think home woodworking tools are 20. I think they're a $20 billion market. So chop saws, bandsaws, tools, hammers, chisels, that kind of stuff. So 3D printing still has a ways to go, but at 65% growth year over year, it'll do it. Other key statistics from the report include the negative 36% year over year drop in shipments of industrial polymer systems. This is folks like Markforged, Stratasys, them fellas. That's brutal. With context recording weak shipments from Chinese vendors, Union Tech, as well as the Western original equipment manufacturers. The context report also suggests that 3D Systems continues to struggle as its top customer has been stymied by weak downstream demand as inflation has shifted consumer spending away from cosmetic dental procedures, despite these observations. So 3D Systems sells the machines that are used by Smile Direct Club and the like, who are making dental aligners. That was their number one source of revenue. And with the overall economic situation of the world, not very many people are straightening their teeth the way they were during COVID with an extra $2,000 in their pocket of stimulus money. So 3D Systems is getting hurt because the demand for the thing that their machines makes just isn't there anymore. And they don't have a lot of diversification as a major revenue driver. There were 7% fewer industrial metal printing systems shipped worldwide. Those shipments were up for 2% on a trail. Powder bed fusion remained the most popular technology. 70%. Yes. Okay. Let's see here. Other stats. Mainly 7% reduction in industrial metal systems. 65% increase in middle systems. Mid-range 3D printers were shown down 6%. Professional systems were down 10%. Basically every group except entry level was down somewhere between 5 and 8%, and then entry level had a 65% increase. Wait a second. Excelled in Q2 2024 with shipments up 34% sequentially, 65% year over year, and 41% on a TTM basis. Creality continued to crush the competition per context, with shipments up 64% year over year and 45% for the full half year, accounting for 47% of all printers shipped in the price class during the quarter. Creality's growth rate was only bettered by Bambu Lab, who again registered triple-digit year-over-year shipment growth, 336%, giving them 20% of the global share. A total of 94% of shipments in the sub 2400 were from the top 4 vendors: Creality, Bambu Lab, Anycubic, Elegoo. So this is interesting. Half of all consumer 3D printers came from Creality. They're the low budget leader. That's not too surprising. And they have high-speed options. The runner-up was Bambu Lab, a company who is effectively 2.5 years old. They've been around for 4 to 6, but only had product for 2.5 years. And Bambu now has 26% of total consumer printer market share. Let me just do a thing here. Consumer 3D printer market size. I know the 3D printing market size, but I don't know the market size of 3D printers right off the top of my head. Right now, I believe it's only about 2 to 3 billion. But we're going to reverse engineer Bambu Labs revenue here, just very briefly. Come on, baby. $2.2 million 3D printers were sold to customers. Yeah, that's about $2 billion. It's $200 million. No, it's about, it's... The consumer 3D printing market is estimated to reach $12 billion by 2030. But its current 2024 value is compounded annual growth of 18%. So 2024 is... Oh, come on, give me the thing. Held the largest consumer... the U.S. has $1.3 billion in consumer 3D printing market. I really want to get this found out, and I should be doing more interesting podcasting kind of stuff, but I want this nailed down. 3D printing its valuation is analyzed to grow from $4.4 billion. Okay, so yeah, I was right. I wasn't right. I was guessing about 2 to 3 billion, and it's 4 billion. So, if consumer 3D printing as an industry is generally valued at about 4.4 billion, half of that comes from Creality. Half of that revenue is Creality, and 25% of that revenue is Bambu Lab. Creality has annual revenues of $2 billion, and Bambu has revenues of about $1 billion. That seems slightly off to me, actually by almost an order of magnitude. But it's not unreasonable either. It's not unreasonable either. Oh, yeah. I think this is including other industries as well, because I don't think consumer 3D printing is that large. And here's the thing: if the U.S. market for consumer 3D printing is 1.32 billion, the rest of the world generally doubles that. So I am going to go back to my number of $2 billion in consumer 3D printers sold, because the U.S. market for consumer 3D printing market share is about 1.32. This isn't 2022, which is a smaller time, but still, I don't think consumer printing has grown that much due to Bambu Lab. So we're going to go with $2 billion as the current revenue for 3D printing, which means that Bambu Lab is doing about $500 million in annual revenue, and Creality is doing about $1 billion in revenue, annual revenue. And you can mark that down a little bit more. There's some more refinement of that data that we could do, but rough-hewn napkin sketch stuff, that is what we're looking at. Side note, Prusa is not in the top 4 compared to the other 4 Chinese-based 3D printing organizations. And that is fair and reasonable. Prusa is probably about a $100 million a year revenue organization, maybe 250, maybe more, somewhere around there. But anyhow, Bambu Lab is a 2-year-old company, came in, took 25% of market share in 2 years. Creality is the incumbent who is holding on and doing well and fighting right along, and excuse me. And then you have everybody else. Wow, what a thing! This is cool. And again, I really appreciate Bambu Lab as a company. Like, they've just done the amount of executional excellence at that organization, from marketing to production, is just fantastic. Oh man. I don't want to, yeah, the context report came out. This is where all this data is coming from. So I recommend going and reading the context report or picking it up over at TCT, where they run through it quite a bit. We'll probably revisit this a couple times. Accounting for 40% class, yep. 330% increase. A 3 1/3 increase year over year. That's not 10xing, but it's not bad by anybody's metric. Most companies barely grow. Here's context, guys, for like growth metrics of these organizations. An economy generally grows at 5%. If your company is not growing at 5% per year, you are shrinking, and you're operationally in a bad position. If you're growing at 10% a year, you're doing quite well. If you're growing at 25% a year, you are doing fantastic. If you grow 100% in a year, you are in the 1 in 1,000 type of an organization that's able to double every year. It's so rare and, quite frankly, very difficult, especially for small companies to go up into that kind of level, and large companies too. To triple or 10x in a year is such a wild ride and so rare, especially when it's driven by actual market demand. Bambu is selling to these printers. They're not a startup that raised 3 times more capital than they did last year and have 3 times as many users on some app. It's a kind of it's a manufacturing organization who's making a physical product. That's difficult stuff to scale. So congratulations to them. That's so hard to do. And with a physical product, it's very, very hard to do. And with a physical product like a 3D printer that is expensive to ship and all the rest of it, to come in and take 25% of the market, gain $500 million in annual revenue, and do fine. I don't think it's $500 million in annual revenue. So 3 million 3D printers probably approximately shipped in 2024, a quarter of those. So we're talking about like 750, well, no, 850 or so, somewhere around there. I'm embellishing. Calm down there in the math comments. You do math anything. But okay. So no, that would be shipping about 1 million units, or 800,000 units or so. Yep, I would presume that with Bambu Lab, with the general numbers that I've seen before. Oh, congratulations to them. That's fantastic. And I just think about other organizations. We've talked about Bamboo Lab before. We've given them an actual dedicated video talking about like their marketing. It's an older video. I recommend watching it though, because like Bamboo does it so well, just on a scale and quality. God, my goodness, they do a good job. But anyhow, still have closed off machines, so they're kind of unuseful in certain market segments though. Okay, that is the news, guys. So, wow, the news has never gone for a full half hour of the show before. Okay, discussion topic then. We don't have any real company announcements. The Etsy plugin and the Shopify plugin are all out there and operating. We are buttoning down for Christmas. We're just making sure we're ready and doing everything that you guys need us to do to produce parts for you reliably over Christmas so that you guys don't have to build 3D print farms yourself, because it's not all it's cracked up to be. That's the company update. We're getting ready for Christmas, and we will continue doing so. All right, the discussion topic then is all the things that need built for 3D printing to go mainstream. 3D printing, definition of mainstream, I would say as a default manufacturing methodology. 3D printing is still very heavily a prototyping source. There's very few applications that use it for final products. There should be more. So what are the stopgaps right now? Very much of it is still kind of the original idea. I did a TED Talk a few years ago where I talked about the problems with 3D printing, and they were slow, crappy, and expensive. 3D printing is still slow. High-speed printers have not solved the slowness part. But slowness is very easy to fix with scale. So if you have one 3D printer and it's too slow, you get two and you just doubled your speed. That kind of math. So the speed is not a real issue. That's more of a scale issue. And you solve the scale issue with demand. Okay, well, how do you increase demand? Well, you make good quality parts. Okay, the crappy part. The crappy part is largely because people don't know how to use 3D printing. It's not because 3D printing is crappy. 3D printing is not crappy at all. It is simply different. So there needs to be more education around how to use 3D printing correctly. And what it enables. Many people are like, oh, you don't have molds and so on and so forth. I mean, we beat this drum all the time here on the channel of the advantages that printing offers over historical manufacturing. And that just takes time to get into the weeds and waiting for a bunch of old engineers to die, bluntly. But, excuse me, there's another way of getting at this, because even if somebody recognizes the value of it, they can't always execute on it. Like if I was an old timer, I would recognize the value and speed of a spreadsheet, but I have no idea how Microsoft Excel works. Therefore, I'm not going to take advantage of that speed. It's happening now with AI and that kind of stuff too, with people much younger than old timers. But there are ways of mitigating that. Convincing people takes time. These sort of transitions always take time. The good news is that 3D printing is about to cross kind of a major milestone, sort of 10-year mark since we went mainstream. 2022 was kind of that year, but we're at the early stage of kind of the next ramp in the Hilbert curve. I hate that thing. We're not in a hype cycle or a part of a hype cycle, just an adoption cycle where the value is becoming clear and more people are utilizing it, so it's growing more. But you wait for people to adopt it, but then when they're ready to adopt it, you have to be ready to catch them, which means that we need the tools so that they can execute on it. AI tools, model generation, specific applications clearly laid out. If somebody comes to you and says, oh, hey, I want to make 3D printed foam or whatever else it was, you have to have foam ready to go. That is the challenge that you have to go through. So there's always challenges with this stuff. But making it as easy as possible to use 3D printing is terribly important. So 3D model generators, guided CAD, good CAD tools, that kind of stuff is a big one. Getting to scale also requires low-cost materials. Now, right now, 3D print, filament manufacturers, I'm going to focus on filament manufacturers. Filament manufacturers are used to quite wide margins on their material, and fairly low volumes. They want to retain their margins. No organization ever says, oh, I'm making 25%, now I want to make 10% just because. They have to continue to make 25%, but the only way that can occur is if the manufacturing cost goes down. And the only way the manufacturing cost can go down is if scale increases so that you can automate more of that stuff in the back end. So scale, again, fixes that, i.e. demand. But now you're in a chicken and egg problem. Is material going to get cheaper first so that you can increase demand, or is demand going to increase so that material costs reduce? And I don't know. Some jerks like us might come along and just make material cheaper, like we did with Tangle. Right. Let's see here. Modeling. We need a model generator. Voice, yes, all sorts of model generation. Industrial scale. Machines designed for production. Again, all the machines that are production machines. Everybody's not focusing on reliable production in the context of throughput. Everybody's mainly focusing on like reliability of it and speed, and they think those are the same as throughput. It's not. You got to knock out parts, and you got to knock out real parts. Everybody's like, oh, a 3D printer can make 1,000 parts. I'm like, yeah, it's this big, and you built out a single bed, and somebody has to sift through it like they're mining for gold. That's not production. Production is a fairly wide gamut of parts, not freaking eyeglass clips. When we think of production part here, we think of the size of a fist. That's a production part. Still small, but reasonable, because this is an average size of what comes out of injection molding. Factory design. Factory design is a big one. No one knows how to build print farms or build manufacturing around 3D printing in an effective fashion, because it's very much like when electricity was adopted. Before electricity, you had factories run on steam. So you had these great big old engines down in the basement, and they would turn belts that would turn pulleys that would turn the pulleys on the machines. So everything was built around this big old steam engine. Then electric motors came along, and they said, give us a great big electric motor. And they put it in place of the steam engine. And they were like, this is about the same as a steam engine, except now I got to run wires to my factory. But then people realized, oh, we can make little motors and put a motor on each machine and then just run wires to the walls. This is way handier than a steam engine with a bunch of pulleys that grab guys and kill them every third day. We're at a similar sort of position with 3D printing, where the business models and the architecture of these systems is not well understood. For example, here at Slant 3D, we started out with mass production. How can we match molding in scale and cost, making 10,000 parts? And now we are reversing that trend and building a factory that can make 10,000 parts that are all different, but still low cost and reliable and good quality. That is fantastically difficult, but is feasible with the technology. But that factory design is unknown because nobody's ever made a factory that made everything. They never have. It's always been constrained. So, but ultimately, much that is expertise, iteration, and more competition, more people building print farms. We've talked about this before. We need way more people building print farms. But most of the other problems are solved with scale. Material cost goes down with scale. People using it goes up with scale. CAD generation tools need to be available so that adoption increases. And yes, and you need machines designed explicitly for production, which still has yet to occur. People are still taking off-the-shelf consumer machines and putting them into print farms, and that works, but that's like using personal computers as servers. It doesn't make any sense. So anyhow. But those are the things to kind of grow the industry. Yes, material needs to get fixed. Quality is fine. That's design expertise. Design expertise is solved by getting scale so that people can use it. And scale reduces material cost. And then we need to design the factories and know how to use this, because even people in the industry do not recognize well enough how to use this technology in a useful way. People don't know what the applications are. People still go through and say, oh, you're making a toothbrush. Well, let's 3D print a toothbrush. And you're just like, you don't want to make a toothbrush that's injection molded with 3D printing. That is a losing scenario every time. If you are a 3D printing service provider going all the way back to the beginning, and somebody brings you an injection molded design and you attempt to print it, you are shooting your own self in the foot, because it's meant for a different process. Don't try to print it. Don't try to be molding. You're not. Be printing. Printing has all kinds of other advantages. Oh, I'll lose the client because they don't understand 3D printing. educate them, make a YouTube channel. It'd be great if someone else was out there doing this kind of stuff. All right. That's it, guys. A lot of news today. Comment down below if there's other topics that you want us to discuss. But beyond that, have a great day, everybody.